Esta conferencia comenzará a grabarse.
So, Mr. Busic, are you following me for the moment? So, shall I continue with the process?
Yeah. So
okay.
Please, go ahead.
Okay, this is the templates of the building of each floor you have. Okay, so this is the process of the template. You should be simplified a little bit, but well. So we are going to, I'm going to explain to you the workflow, okay, of our philosophy, of our multidisciplinary, multi-user workflow, okay. So this is, do you know this? Have you seen this platform, Build Server Center platform? Hello?
Yes, we have.
Have you seen a little bit this platform?
Last week we were
Okay, I understand that my colleagues showed you the platform last week, okay, with the BIM projects, etc. Okay?
Yeah.
Okay, so I'm going to create a new project in order to show you how to communicate with the templates with a BIM model, okay? So, for example, let's create a test of, for example, Busic project, okay? For example, the type of project, you have different type of project, different roles for the different team members of the project. So we are going to, for example, let's test, or for example, this is a project type selection. The visibility in the platform should be visible for all the members, all the users in the platform, in order to search for collaborations, for partnerships, visible to your contacts, only to your agenda, or not visible to anyone, it's only for you, for example. I'm going to let visible to my contacts. Afterwards, we can invite you to this project, for example, if you are already logged in with the platform. So the collaboration request, for example, should be open to my contacts, and or closed or open to the whole platform, depends on the visibility, okay? So description should be, for example, dwelling, Korean dwelling, for example, or house, however, whatever. So create a new project. So this is the dashboard of the project. Obviously, when we create a project, it's void. There is no files here. So here, where, for example, the files are void, there is nothing here. And the work team here, for example, this is Vincent account. The Vincent account, this is the owner, the creator of the project. Should be the role, for example, the BIM manager or the responsible of the project. For example, what I'm going to do is invite myself for the project, invite a user. So for example, I'm going to search myself. This is me. And I'm going to, well, I can actually assign myself as moderator, editor, collaborator, whatever. For example, let's assign myself as moderator. With this, I can view, add, modify, delete files to the project, and also I can invite other team members. And also I can assign an area of interest. Maybe it could be structural engineering, maybe it could be MEP, mechanical, electrical, plumbing, whatever, okay? So, or even architectural design, for example. So I'm going to send invitation. For me, I should receive in my account an email in order to invite to collaborate with this project. Okay. So this is the way, the process to invite to create team members for the project. So once we have the project created in a platform and invite and configure the different team members of the project, so we can start the process. So what we need in this BIM technology, we provide. What we need minimum is a BIM model, a 3D model of the building. So we are going to use at least, for example, one of the floors of your building. Just an example, little example, in order to create a 3D building of the project and to store the IFC file here in the platform. So let's go to the suite, CYPE Suite. CYPE, I'm just more used to CYPE, for example. So I'm going to launch to 2020 version. I'm sure that you're familiar with this. Last week, maybe our colleagues told you that we just published or released the 2020 version. So here is the suite, the CYPE Suite, with all the elements, all the domains, all the different tools we have. Also, we have another tool that you can also download and buy and use from the BIM Server Data Center platform. So we are going to start with your templates in CAD, your CAD templates in 2D. We are going to use them in order to create a 3D model of the building. For example, with this IFC builder. IFC builder is our model, 3D modeler, free modeler from our suite, so you can use it. Every user can use it if you don't work with, for example, with Revit, ArchiCAD, or Plan Bentley, or SketchUp, or whatever other BIM models of the market, you can use it. Okay, so it's free, and so you can use it at whatever time. So I'm going to launch it, IFC builder. Remember now in the role, maybe we should you can connect with your account. I'm going to connect with the account that Vincent is going to connect with his account. Are you following for the moment, Buzik? Or other guys that you are there? Are there any questions for the moment?
No, just keep going.
Okay, perfect. So we are going to create a new project. This is remember that we are in the process of creating the. I insist. Sorry if I insist sometimes about the same thing, but it's better. I think it's better to understand the process in the beginning very clearly. So remember, if you, for example, if you start from SketchUp and you are able to generate an IFC4 file, you avoid this process. You avoid this stage of creating an IFC model from IFC Builder. So the target now is to create an IFC file. This is a standard file for 3D. So you can generate wherever with SketchUp if it's able to do it. We guess that it's possible to do it with SketchUp. But if not, you can use this tool, this IFC Builder free application, okay? So we are going to create a new file. Let's create a Korean 3D model, for example. Okay, this is CBIM extension file. Description should be house or dwelling, whatever. So we are going to accept. So normally we are going to set an empty job, okay? An empty job, and we are going to establish the different parameters in this wizard that is the software is going to tell us. So minimum, we are going to provide ground floor and roof. Here we can modify the reference of each floor and the height. So we can add floors and groups above the floor, above the ground level, and below the ground level. So it depends on the building. I can create, for example, if I have a group of different floors that are already, which all have the same distribution, the same architectural design, we can group and avoid and speed up a little bit the process of introducing the building, okay? So we are going to create, for example, one floor, floor one, ground floor, and a roof, for example. This is very simple, okay? That's well, an example, a test. So we are going to accept here. And now the software is going to ask us if we want to introduce the drawing templates. If we click, this software has two possibilities of introducing. One is to start from templates, CAD templates, as you have passed to us. Or the other possibility is to, if I click now here, I'm going to introduce the building by coordinates. I can, if I have the drawings in paper, or even I have only the coordinates, I don't have a vectorial file or a electronic file. So maybe I can introduce all the building in 3D by coordinates. It's another possibility, okay? So you have both possibilities. Here, normally the process is to click yes, and I'm going to search the templates. So I'm going to search from my desktop, the files I have copied from you. For example, this is the original file you passed to us, and this is a clean, a little bit simplified, the information. But well, for example, it's very important to establish properly the origin of coordinates and the scale. Well, I'm going to open it. So this is your files, your different floors, levels of your building. So here we are going to here we have a tool in order to check the origin and the origin of coordinates. For example, here one of my colleagues cleaned a little bit the template and established the origin of coordinates here. And also, well, here the scale is not very well defined in your CAD software, so I have to modify. So I'm going to make a zoom here. Normally, this process is already done in your template in your CAD software. Okay, so for example, here is a tool to change the origin, the scale. For example, I'm going to establish intersection endpoint. Let's imagine this point. Cancel, sorry. This point and this one should be, for example, 82 centimeters, for example. Let's imagine this is the real dimension in meters in the real job. So with this tool, I'm going to scale the template, all the templates of we have imported here in the software. Another possibility is to establish a visible area and also change the origin of coordinates. Normally, if we have different floors, we have to establish different areas and different origin of coordinates in the different floors. Okay. So we are going to accept here. I'm sure, well, this is the template. This one, okay. So this is the second one. I'm going to accept. I'm going to attribute, for example, in the different groups, here ground floor, we have this template, and floor one, we have this template, for example. Remember here, I can copy, I can deactivate different visible areas, so we can do many things. Or normally another way of working is that to have different templates, DWG files, with all the floors separated in different files. This is another possibility to work with the software. Normally, I'm more used to that. I have, for example, ground floor, floor one, floor two in different DWG files. So I import the several files, and I attribute or assign to the different groups of the building. Okay, this is another possibility. So I accept here. Now this job is going to be created. So this is the environment of the building. Okay, if I make it, well, here I can modify the floor groups. I can copy. I can make the orientation. For example, the orientation here. This is the file. I don't know if I established the. Well, this is according for the scale. Maybe the scale is not very well defined, so. Okay, so. Okay, the orientation of this is the north. The orientation north, I can modify and establish the direction of the north for this building. For example, let's imagine it's this way. So I go to, let's go and make a zoom here. This is the part which I'm interested in now. So for example, here, well, the speed of the process of introduction depends on the quantity of the information of the templates. If the template is overcharged of information, it's going to be very slow. If you simplify a little bit the template, we are going to make a very high-speed introduction, okay, process. So, for example, let's with this process, with this view, I'm going to just introduce some walls and some spaces here. For example, architecture, walls and partitions here, external wall. Remember that we are going to define only the 3D model of the building. So let's define wall one, for example, with the thickness, let's imagine 20 centimeters, for example. We can modify the units of each tool of CYPE. You can modify and manage the units here. I will do it in a minute, and I will show you how. So here I can make the introduction just approximately, more or less following the contour. I can activate the object snap selection for the templates if we want to be precise or accurate. But if not, we are going to make more or less the introduction. I can modify the reference line for the walls, so as you wish. For example, more or less, this is the, sorry? Are you have any doubts, Buzik? Or it's okay? Okay, so more or less, okay, I'm going to deactivate. Yes, the thermal is deactivate. So more or less, if I don't be precise, don't worry about this. This is just an example, okay? But as I told you, you can use the template of snap selection to be accurate. So following more or less to be like this. And for example, I don't know exactly the distribution. I don't know, maybe, I don't know if it's at the RAS or something like that. Well, I'm going to avoid this. Okay, so this is in whatever moment I can activate or deactivate the template with the F4 shortcut of the keyboard. Okay, so we can activate or deactivate. So here, this is the wall, the external wall. For example, let's do it some internal walls. For example, walls and partitions. Let's imagine partition 1 with 7 centimeters thickness, for example. Let's create this wall. For example, let's imagine here over here. Remember, I can modify here the typology just over here. For example, this one, or well, just up to here, for example. And here I can continue over here. If I'm not being accurate, sorry about that. Okay. Okay, for example, F4, you can see the distribution, for example. I know it's not very real from the real project, but you can, we don't have time to do it. For example, let's complete the here. For example, this point, yes. Okay, more or less. This is an example of some spaces. So what can we do here now? So for example, let's introduce some doors or some windows. So we go to openings. We have here doors. Let's introduce some doors. Door 1. The width is 80 centimeters, or we can deactivate or force or not the width and the height. So for example, door 1 here, let's the first point here and the second point over here, the 1 point here. Obviously, to introduce the doors and windows, we need the walls previously, okay? For example, the floor slabs, the roofs, and the vertical walls, it's the order is undistinct. So you can introduce, first of all, the vertical walls and afterward the horizontal elements, and vice versa. So it's not mandatory to do it one way or another. But for the doors and windows, you need previously the vertical walls, okay? So external camber tree for the windows, we go, for example, typology window 1 or glaze 1, wherever. The width is going to be deactivated and the height is going to 2.20 meters. We are going to accept here the height above the ground is going to be 1 meter, for example. And let's imagine here there is a window over there, for example, one window here, another window over here, and another, yeah, just obviously, sorry about it if I don't follow exactly the template, but it's just an example. So another window, for example, here, another one here. Let's create another typology of door here, for example, for these elements. So for example, door, let's create another typology, door 2 with this height, and the width is going to be first here, 1 point and the other one, for example, door 2. So if I deactivate the templates, so what can we do here? How do we know that we are going to do the things, that we're doing the things properly? If I go to the 3D view, I'm going to save the changes from time to time, go to 3D view all the floors. And here we have the material of the edges. So this is what we are creating here for the moment. You see, Buzik, you see how we are doing here for the moment?
Yes.
This is very simple. Really, if we have the templates really simplified with the minimum size required, with the minimum information required, introducing the walls, the slabs, the doors and windows, etc., is very simple. It's very quickly to do it. Okay. So this is an example of some examples of some walls, some doors, windows. Let's do it the floor slabs, for example. We are working now in the ground floor. So we are going to establish, for example, the slab on ground floor, floor slab, screed or slab on ground floor. Let's go screed 1. This is 25 centimeters, for example, a mat foundation or something like that. Or let's establish here. Even I don't need the template because I'm going just following the contour. For example, obviously, if there is some terrace here or something like that, I can modify. But for example, this is the floor slab or the slab on ground floor because this is lying on the ground. Here also you have a shortcut to the 3D view of each floor here on the left. Okay, so this is quite nice. Also, I can modify here, establish another typology. For example, is something different, slab 2. For example, let's imagine there's 10 centimeters because there's different layers here. So I'm going to attribute a different slab on ground here, for example, without avoiding overlapping. Okay, this is another typology. So what can we do here? For example, we can move with these icons. I can move up or move down from floor to floor, or go directly to a particular floor. Floor 1, you see, this is the distribution in this continuous line, the distribution of the ground floor, the floor below. Can activate or deactivate. I can also activate the templates. Okay, you see? Or if I have several templates, I can activate the several templates we have for the different distribution of the different floors. Okay. So really what we have to do here, if in the template view manager, is establish, copy this template and establish different origin of coordinates for the different floors or separate in different files. Okay, remember that. So let's imagine that the distribution of the floor 1 is very, very similar or particularly always the same from the floor, the ground floor. I can copy here, project group, copy group. I am going to copy from the ground floor. Okay, so I'm going to copy everything here. So this is it. And now I'm just modifying. For example, let's delete something. For example, this wall. I'm going to delete also this one. And for example, this one. I'm going to delete, for example, this door, and I'm going to establish another walls. For example, partition 1. Let's imagine this is something very different here, something like that. For example, I don't know. This is a imagining. I'm inventing it. Okay, just to show you how to modify from the different floors. So, for example, this is the distribution of the, I'm going to add, for example, some doors here, some door here, door 1, type 1. I'm going to add a door here, for example, another one over here. Okay, yes, this one. So here I'm going to change the typology of the floor slab. If I'm going to edit here, this typology is on the ground floor. So I have to modify to internal floor slab because we are in between ground floor and floor 1. Okay, so floor slab 1, for example, 30 centimeters. And yes, you see the difference of the hatches of the pattern. This is like orange, and the other one on the ground floor is like gray. If we go to the roof, it's going to be like, well, I'm going to show you. For example, we move up and we are going to the roof. This is the roof, you see? So I'm going to the option flat roof or slope roof if you want. What are more used to do, slope roof or flat roofs in Korea? Flat, maybe? For your templates? Well, this is a slope roof, isn't it? Buzik, are you there?
Yeah, yeah.
Well, I'm going to show you how to introduce, for example, this slope roof, okay?
Yeah.
In this modeling, for example, how to do it. So I'm going to the slope roof. Let's create slope roof. This is the thickness is going to be, for example, 20 centimeters. And I'm going to just introduce just with the distribution. For example, yeah, well, I'm going to do it in one slope only, just to simplify. Okay. By default, if we go to the 3D view, you will see now the building, the invented building, okay? So here we can start doing things. For example, let's do it some section here, you see? Okay, now.
안 움직이세요. 드래그.
Okay.
드래그.
Okay, now, so you see the section with the arrow. So we can see the architectural design of the inner part of the building. Okay, you see. So
Yeah.
we can establish different sections here, different axes. Okay, or in the Z axis also. For example, we can establish the different buildings. So there are many things, many tools here. For example, we can, for example, let's see the internal part with the hiding the walls, external walls. Okay, you see this is a very little example and very simple. This is the flat roof. I'm going to change it because by default it's flat. So I'm going to establish the slope. We go back here where the floor slabs, introduce elevation changes in roofs. So this is going to be, for example, let's imagine it's going to be 2 or let's 1.80 meters. This point, to establish a slope, you will need 3 points of introduction. So 1.80, and the minimal height is going to be 0. The elevation changes. So this is the slope. We come back to the 3D view. We will see the slope roof. Now you see the slope roof of the building. Okay.
Yeah.
So this is just an example starting from your templates. Even if it's not your real building, but it's how you have seen how to do it. So what we need here, imagine that we have completed the whole building with all the introducing all the constructive elements, the walls, the floor slabs, the opening, etc. What we need here in the architecture is tab, architecture part, we need the spaces. For example, let's introduce some spaces here. A space is new. For example, the type of prison should be, for example, bedroom. Let's establish bedroom. Should be, for example, here we can establish bedroom 1 here and bedroom 2, for example, here. And this could be, for example, the let's change the description and create another one. This will be the corridor, for example, or the hall of the dwelling. Let's click here. Just click on the space meant to this room corridor, for example. And with this process, we could do the same. For example, I don't know, maybe this is the dining room. Let's create another one. Dining room. Okay. So this is going to be the dining room. It's not very real, obviously. So dining room 1 or dining. This is the reference. In the same floor, we should establish different references for all the spaces of the floor. Okay, so we should do the same in the floor 1. If we go up, the floor 1 is going to be the same. Go space, new, we are going to use, for example, dining room. This is going to be the dining room of this dining room 2, for example. And let's change to bedroom, for example. This is going to be bedroom 1 of this dwelling. And finally, for example, the corridor of this corridor of dwelling 2 or floor 1 or whatever. Okay, so this is the way to do it. Okay, so we set changes. So imagine on this process, we continue introducing all the spaces of the building, the different floors. So once we have all this process done, we can just go to results and analyze the architectural, part, the geometry. So if we analyze here, we are going to see the information of the geometrical information, build surface, internal surface, net floor area, volume, etc. You see? Okay. Yeah. You see all the information of each element. If you want to change the unit, now is the time to show you how to change the units here in the configuration icon, units. We can modify and work in an IP system, imperial system. You want to modify in feet, or individually we can change inches, feet, or whatever other units. We can change the accuracy, all the decimal digits, we can modify it here, okay? So you can modify individually or by the global system. Normally I'm used to international system, okay? So we accept here, and this is the information. Also, we can attribute in architecture the group of spaces. For example, let's create each group for each floor. For example, ground floor 1, and another one is going to be floor 1 in another color. Okay, so let's attribute now, assign to this, for example, ground floor. I'm going to attribute all the spaces to this group. Okay, you see, ground floor. This is in order to export to the different tools, open BIM tools of the CYPE for thermal calculations, acoustic calculations, electrical, etc. Okay, so we move up to the floor 1. I'm going to attribute the spaces for the floor 1. Okay, this is. So this here you will see the group of the spaces, which contains all the spaces for each group we have created. Okay, so we are going to save it. Now imagine we have finished with all the introduction in a real project, in a real building. So now, once we have the BIM model already completed, we can export to the BIM project. Remember, previously we have created the test basic project, so we are going to export it. Here, one thing we should do here is, for example, let's add this is the Synchronizer. This is a free tool you can download here. This tool, this is the Synchronizer. This obviously is a free application. We need to communicate the platform with the tools, with OpenBIM tools, and with the modeler, and with every architectural tool or calculation tools of our suite. So we need this tool in order to synchronize the platform with this tool. So now Vincent is going to add his account in order to communicate this project with the BIM model. Any questions for the moment? Everything is clear, more or less. Okay, so this is the account from Vincent. So here, well, I'm going to scan here. Well, all the yes, here you see this is the Vincent account test basic project. Okay, this is the project from Vincent. So here is going to synchronize all the elements. So now we are going to export. Once we have checked that the account is connected and the project is here, we are going to export from the IFC builder. We are going to export. We are going to link to a BIM project selection. This is the account from Vincent. We are going to select the project. So test basic project, accept here. So this is the Korean, for example, 3D model, okay? IFC file. Remember that we are sharing in this BIM workflow, the target is to share standard files, not native files. We are not going to share the CBIM file from IFC Builder. We are going to share the IFC file. So this is the current 3D model IFC file. Remember that if you have already the IFC file from SketchUp, we should avoid this process, this stage of introducing the model here. So we are going to export the templates and we are going to accept. So let's wait here. The synchronizer should be here. So now test bullshit project should be synchronized. Let's check it. We are going to refresh this website. Let's go to files. Maybe it's not synchronized yet. I'm going to do one thing. It's just to avoid everything and select all and just only test bullshit project. Well, now you see this is uploading only the 3D model, okay?
Yeah.
So I'm going to the platform, yes, refresh again. So now we should see the file. Okay, this is the IFC file, you see, already uploaded. We go to the dashboard, we will see the 3D model. You see the 3D model? In the BIM modeling, this is the architectural design. Okay, here we can establish the different, well, sections, view, okay, from the different perspectives, etc. So here is the BIM model is already prepared in order to communicate with the different open BIM tools. Here we have the GLTF. This is the view of the GLTF, and this is the IFC file we have of the architectural modeling. Here you have the changes, the historical changes to have a traceability of the project. So here we have in the files also we can see the IFC file, the GLTF, and the DWG templates. You see, all the templates we have imported also exported here in the platform. Another interesting thing, even if this is a cloud server-based solution, but you will have always a local copy in your computer. Here in your C local hard drive, you have this C BIM projects folder, and we can search for the user. This should be Vincent. Yes, this is each one has a number, a code. Should be Vincent. So here we have test bullshit project, and here we have all the files in a local copy. So you will have always a local copy of all the files in your computer. Okay, so here we have the GLTF, the DWG, and the IFC files for this project. So we only have the information in the platform and in your local copy. All the team members of the project will have the same elements. Okay. So now we are going to, for example, I'm going to deactivate here. I'm going to, for example, access my project with my account. I'm going to log out here. So I'm going to log in with my account now, and I'm going to access this project. And this is me. So this is my project, well, my home, the home of my platform, my account. So here, this is the test bullshit project. Here we have notifications, and here I have a notification of an invitation of collaboration to this project. You see, Vincent has invited me to collaborate in this project. You see, this is a notification. Also, I will have in my email, I don't have here my email, but in my email, I will have a notification by email to access this project. And in this project, I have, you see, the test bullshit project to this element. Okay. So I'm going to, I see the files here, and I'm going to start to work with some tools. For example, I'm going to show you the thermal load calculation and the ducting design, for example. So let's go to the sector part. We have this temperature loads. This is also a free application because in our firm, our company, we develop not only paid applications, but also free applications, depending on the target. So separate loads, this is a load calculation analysis for according to Azrael methodology for thermal load calculations. So we're going to go thermal loads, separate loads. I'm going to open it. Now, meanwhile, I'm going to activate my account here in this synchronizer. For example, I'm going to add my account also. We can activate just up to 3 accounts on the same computer, as you can see here. Sorry. Okay, let's unselect all. For example, this BUSI project. If you want afterward, but I think the last week they show you how to. This is that BUSI project. Okay. So this is my account. I'm already logged in. So let's go to separate loads. I'm going to log in with my account here in this tool. Remember, think about that we are now, imagine that I'm the thermal engineer specialist. So I'm going to do the thermal load calculations charged by Vincent to me. So Vincent has invited me to the project. And now I'm in charge of doing the thermal loads calculation. He has done the modeling, the 3D modeling, and now I'm in charge of doing the thermal loads analysis or the ducting analysis, the electrical or wherever, the plumbing, wherever. So I'm going to log in with my account. Let's connect. Sorry. Wow, now I'm connected. So let's create a new file. Let's do, for example, thermal load Korea. Okay. So this is HVAC extension file. This is the native file of thermal loads analysis. This is my file, my property. So I'm going to link to a BIM project. This is my account. I'm going to select the project. So in the selection project, this is the test BUSI project. I'm just, if I'm being part of the team member, I'm a team member. So I accept here. So this is the 3D model. You see, this is the IFC model. And another interesting thing is that now that I'm the thermal engineer, for example, the thermal specialist, so I have been provided with this BIM model, but I don't know which software has developed it. I don't know if it's IFC Builder or Revit or Allplan or SketchUp or Archicad. I don't mind. I only mind that it's a BIM model in IFC format, in a standard format. So I need the architectural model in order to provide the layers, the materials in order to make my calculations. So this is very important also. That is not important the original BIM model who has done it. Okay. So this is only the minimum information I need to make my calculations. So this is, well, I'm going to import the edges, the shadow description. And if I had a typology of libraries, because I have worked with previously with the software in another project, I could search for typologies in the library. In this case, I haven't, in this particular PC, for example, I haven't been working before, so I don't have a library. So I accept here, and the software is going to read the BIM model, the IFC file. I accept here. So this is the environment you see of the thermal loads analysis. We have here the thermal loads calculation BIM model, the IFC file here on the left bottom of the screen. We have the building and project information of the building in the project tab. And here finally in the thermal loads tab, we are going to make the analysis. Okay. So let's start with the building libraries to provide the materials and information of the spaces. Okay, so here we have, for example, you can see here in the spaces, obviously there are everything is full of mistakes because we have to provide the information. So here we have the spaces, we have to provide the information of the internal parameters. So a bedroom, we did here. What is the bedroom for me? It's an occupied, heated and cooled with this cooling and heating parameters. The ventilation, for example, should be 8 changes per hour should be 1.2 changes per hour, for example. We have here some particular buttons to edu from ASRA standards that you can provide. If you don't know, if you have no idea which parameters you can provide for a typical bedroom, you can go and consult the ASRA standards and import here. Okay, if not, you can introduce manually. You can also activate infiltrations calculations. You can establish schedules. This is very interesting. For more completability, you can make daily profiles. So in daily profiles, you can create your daily profiles in order to establish the different percentage of use for the occupancy, for the lighting, for the ventilation of the different daily profile typical day for calculations. Okay, so you can create your own daily profile in order to provide your calculations if you want. If not, you can deactivate. The internal heat gains occupancy, for example, this is for a typical bedroom, 2 people, for example, with these parameters of calculations. Internal equipment, if there is or if there isn't, and lighting, for example, should be watts per square meter, for example, 18 watts per square meter. The spray fraction should be 80%, and the random fraction should be 75, for example. I insist, if you have no idea to what parameters you can provide, you can import from ASRA standards, from ASRA handbook or ASRA applications manual, load calculation, etc. Okay. Once you provide the parameters, you accept here, and the mistake is going to disappear because you have provided all the parameters. We can do the same for the dining room and for the corridor. Let's establish for example, 80 liters per second. Internal gain, the people should be 5 people, for example, and the lighting should be 90% and 120 watts, for example, for the dining room. And finally, for the corridor, should be internal gains. People should be occasionally 1 people, for example. Lighting should be 11 watts per square meter, 70%, for example, space fraction, for example, and the ventilation should be 1 changes per hour, for example. Okay, for example, this is just an example. So this is once we have provided internal aid, and we remark here in the 3D view, we can see in the 3D view we can see remark the bedrooms. Where are the bedrooms? Where are the corridors? Where are the dining rooms? We have provided in the 3D model. Okay. So once we have finished with the introduction of the spaces, we can pass to the facades. For example, all the constructive elements. Facades. For example, here we have wall 1. This is the wall 1 external elements. So we have we can edit here and provide the layers. Remember, in the 3D modeling, we have only provided the geometric and architectural or dimensional model, not information of layers of materials. So here we can provide a simplified input, a global parameter input, or detail, layer by layer. I can provide manually all the materials with a technical data from some manufacturers and vendor, local vendor from your region, for example, or you can provide different libraries, Spanish, Portuguese, French, Moroccan, Italian, international layers from standards ISO codes, or from ASRA. For example, let's go to ASRA, masonry, for example, this brick, for example. Let's go and import this brick, and also we can add another layer. For example, let's import from ASRA some gypsum, for example, board or plywood. Okay, with this, we can copy with this layer and we can move, for example, and let's imagine this. This is some particular wall, for example, with this total thickness. Here we have the information, and here the software is going to automatically analyze the heat transfer coefficient, the U value of the wall. This is automatically analyzed by the software. This is very important and very interesting. And the thermal capacity also. Okay, so we have with this external wall the information here. Instead of doing it manually, wall by wall, you could import global solutions from ASRA Fundamentals, the handbook. We can import, for example, brick walls or stud walls, external insulation walls, and curtain walls wherever you want to do. Okay, with the U value and the external solutions, the global solution with all the layers from Azure. Okay, also you can import. This is always available with the software. Let's do it the same for the internal walls. Here, for example, internal walls should be here, partition walls. Let's edit here. And for example, here, let's import a brick wall, for example, this one. And this is going to be a brick wall, for example, for this internal wall. Okay, you see? And the facade is the same thing. We are going to edit here and import another brick wall from this one, for example, or another typology here. This is the process of assigning all the elements from here, okay? So once you provide all the layers, that's to say for manually or simplify a global parameters input and detailing layer by layer, or the global solutions, predefined solutions we have included in the software, you are going to see that the mistakes are going to be disappearing here. You see? So let's move on to here. Underground walls. There are no underground walls here, as you can see. Also, as slab on ground floors, we can see the slab on ground floors here in the ground floor. So we are going to attribute the different layers. So let's go here, add a new layer. For example, from Azure, let's go to, or from a standard maybe. Yes, the international codes. We have concrete, for example, this concrete or reinforced concrete or the medium density. We are going to provide a 20 or 25 centimeters layer for concrete. We can modify the color if you want, or the mesh to the representation of these inputs. So this is the layer concrete, only concrete for this slab on ground floor. For the floor slab, we could edit and do the same thing. Go to create a new one. For example, I'm going to, go to the Spanish library, for example. And the Spanish library, we have predefined slab for slabs. Here, for example, we have these slabs. Sorry if you understand, this is in Spanish, don't worry about it. This is a typical solution for a slab between floors, 25 centimeters, okay? So we have, and we import here, okay? What else? In the roofs here, for example, if we provide here, for example, if we edit here, we can, instead of layer by layer, we can import predefined solution from Azure. For example, slope frame roofs. Let's do this slate or tile, for example, this one. This solution with this U value, this is very good U value. We accept here, and this is all the layers that contains this global solution from Azure. Finally, we will see the information for slate or tile, wood, ceiling space, bad insulation, and gypsum board. Okay. What else for the doors? You see the process, you understand the process. We have imported the BIM model, we have attributed the internal gains for the spaces, and all the layers of materials for the constructive elements, typology by typology. We are going to do the same for the doors. For example, a door typical for or 2.20 watts. If you see these icons is is in order to generate libraries in order to use in future projects, so you can use it. This is 220 U value typical from a boot door, for example. So here the mistake is going to disappear. And finally, the glazed openings. Let's edit some windows. The glaze fraction is going to be, for example, 2.80 watt per square meter per Kelvin. The opaque fraction should be, for example, 16% and 4 watt per square meter per Kelvin for aluminum, for example, aluminum with thermal break. For the opaque fraction, we are going to do the same with this let's attribute all the windows the same typology. If we go here, I'm going to set the changes. Let's attribute. Viewpoint XE, and the opaque fraction should be 22%, and for BAT, okay, for all the elements. Voila, this is it. And you see the information for window 1 with the different dimensions we have provided in the BIM model, in the BIM model. So once we have provided the skylights, there is no skylights here. The linear thermal bridges is something that is optional. If you import the edges, you can provide the thermal bridge analysis. I don't know if you guys in Korea, you analyze the thermal bridges. You can avoid it in the import phase. If you want to consider it, you have here all the edges and we can process them. Here we have the edges process configuration. We can establish different criteria from ISO codes, thermal finite element methods, manual introduction from different codes. And finally, we are going to provide a processing edges here. We are going to accept. And here is the automatic process edges. Here is the representation of all the edges for the thermal bridges. And it says, if you don't consider anomaly in your calculations, you can avoid and import edges phase first stage of this import.
Usik, Usik, do you use the thermal bridges or not in Korea? Are you used to calculate using the thermal bridges? Please.
Well, excuse me. What's your question?
If we are asking you if you are in Korea, normally if it's mandatory or you are used to calculate or analyze the edges for the thermal losses, for the thermal bridges of the, if you process the edges for the thermal analysis in your
Thermal
building.
analysis. Thermal analysis.
See, yes.
Maybe the buildings, big buildings are considering, gradually considering about the energy saving. But normal houses are not much.
But yeah, I understand. But in great
So
buildings, for example,
normal houses are just installed air conditioner.
yes.
And also we are warming by the floor, heating the floor, not the air.
That's for heating. Okay, perfect.
Yeah, so different.
We have control. Yes, what we are doing now is the previous step from the equipment selection or the system selection for the sizing the ducting or sizing the equipment for air conditioning or underfloor heating. We are doing the previous phase. It's analyzing the thermal loads. We need the peak load in order to select the equipment afterwards. So in this thermal analysis phase, so we just were wondering if you analyze the thermal bridges. Just was the question. Okay, don't mind.
Do you
go ahead? Yeah, we need to just learn the your solution, each solutions. Yeah.
Do you analyze the edges of the building, like where the two corners meet? So for this particular section, this line here is an edge. Now it has different properties in terms of losing energy. In Korea, do they analyze these sections in their houses or just big buildings? Okay.
Okay, don't mind. If you need further information, we can send you further information for thermal bridges. Maybe you will understand, or by mail Vincent can send you some information. Maybe you could understand clearly what it is.
Yeah. So leave the questions, through the email. Yeah, we will try to find out.
Don't mind. So finally, once we have configured all the parameters of the internal spaces and walls and thermal bridges, we finally Here we can console the 3D view, and we just verify that everything is properly defined. This is already taken from the BIM model, so we don't have to do anything really for the project part. So because we all the surfaces, area volumes, dimensions, and coordinates, really they are introduced in the BIM inputs. So let's move on to the thermal loads analysis. So we go to the thermal loads analysis. So we have here to provide some hypotheses of calculations. This is a house, greenhouse, so it's very simple. So we are going to provide, first of all, is the location data. In the location data, we have the weather database from Azrael. We can provide manually all the data here, and you can generate or manage your own libraries. But normally we can start from the weather database of Azrael. This has more than 6,000, I think, if I'm not wrong, 6,000 locations all over the world. So let's find out if we have some locations for Korea.
The
Okay.
report. No, it's North Korea.
Oh, sorry about that. Sorry.
South Korea.
Yes. So we have this Seoul.
City.
Okay, we have just to accept. So this is Seoul importation. Okay, we are going to accept here. This is all information for example, for your city of Seoul. You have more than cities for your country. So here, even you have imported from Azure, you can modify it. You can customize and do whatever you want. Okay, so we are going to accept here. And this is all the weather data conditions for your location. So let's create a hypothesis of calculations. Here, hypothesis, let's create a zone. And here, this is a zone, very simple. We are going to provide all the floors of this building because this is just some text. So we are going to provide the ground floor, all the sum of the spaces we provide of the ground floor and the floor one in just one thermal zone in order to analyze the whole building. So we save the changes and we update results. So this is very quick. So we have this zone and we can see this is all the graphs here, the simultaneous peak cooling load, the peak heating load, and the overview calculations. Here you will find some complete reports here also. This is the load calculation summary for heating and cooling for this thermal zone. This is what we are going to use for cooling loads in order to select, for example, the heat pump or the cooling tower or whatever we are going to use to produce the water or the air-to-air, the VRF external unit or whatever, in order to the total watts peak power. And also we can do space by space the total peak power we need, the peak load we need for the individual equipment selection for the cooling and for the heating. So this is a summary, and in order if you want to consult the detail space by space, you can consult here all the total conduction heat gains, thermal bridges gains by windows, by walls, by slabs, by the internal heat gains for the occupancy, for the lighting, for the ventilation. You can see also the details space by space. This is very detailed. All the reports in CYPE tools, you can share it by PDF with a colleague, with your team members, with us. If you want to make some technical consultations, you can export in different formats: PDF, docx, HTML. For me, the most interesting ones are PDF and docx overall, because you can print in paper if you want, or do whatever you want. Okay. So where else you can consult? Apart from the complete report, you can consult space by space. For example, the RTF parameters. This is very tough to do it manually. The overview calculations, what we need to do according to the RTS method from Azrael, and also the complete cooling load reports for each space. The ones you have seen on the complete report individually, space by space. If you want to analyze particular, for example, what are the losses for ventilation, you can go over here, the overview calculations for ventilations, losses, and you can consult the sensible cooling loads month by month in this graph and the latent cooling loads. According to its elements for the facades, for example, you have the cooling loads, the opaque surface, the conduction factors, etc. There are huge amounts of info here you can consult. Okay, so this is very, very detailed. So you can consult and you can obtain the different reports individually, space, by zone, or by the whole hypothesis. The reports here, also you have some extra reports, very, very interesting. For example, the description of materials. You have some quantities here for some of the constructive elements. For example, the screed. This is the slab on ground floor. You have all the surface for this screed with the different elements. And for example, for the walls, all the square meters for the walls introduced here. All the windows, the quantities. So this report is for the whole building. This is very nice. So once we have finished with the thermal loads analysis, we are going to export the results to the project, the BIM project. Remember the project. Thermal loads, for example, Korea, we are going to accept, and we are going to export the IFC results to the BIM project. Let's come back to the, let's see if it's synchronized. I suppose so. So if we come back to the, let's refresh it. Voila. We have, this is the thermal loads calculations. This is graphically, we cannot see here. Well, yes, really, yes, we can see the thermal model here. We can see this is the architectural modeling. So we can make transparent, and we can activate, for example, by layers, the thermal model. So you can see here the different elements. If we pick up here, this is all we have exported from thermal loads analysis. If we come back with double click here, you will see the information of each layer. You see, this is very interesting for architects and also for engineers also, but obviously for the BIM manager, the information of each layer and the U value of the thermal resistance according to each layer. Okay, this is quite nice. And this is all exported only contained in the BIM platform. You see, the information is increasing. We are consolidating the BIM model step by step and improving it, introducing the information for each calculation. In this phase, we have provided the thermal loads analysis. Okay, this is the thermal model in layers or by elements you can consult. Okay, so let's move on and go in this CYPE Suite. We have also HVAC, for example, for ducting sizing. I'm going to show you for size ducting for this HVAC installation. I'm going to show you how to do it. This is another tool we have. Have you understood the process of importing from thermal loads analysis, assigning all the elements on the internal parentheses, calculate the thermal loads, and export it, come back to the BIM project? Have you understood this process for the moment, Mr. Buzik?
Yes.
Okay.
Yes.
Okay, thank you. Perfect. So if we come to another open BIM tool, this is HVAC for ducting sizing. Well, let's create a ducting Korea, for example, analysis. We are going to import a BIM model. We can work with this. Almost every tool is we can make a design without a BIM model, but obviously the most interesting thing is to start from a BIM model, like this example today. So we are going to, select a project. Let's pick up the project we are working on. So test Buzik project, accept, click on next. we are going to read the same thing, the architectural model, and also you see the initiator is IFC builder. This is the 3D model, the main model we need, but also we are going to make the importation of the additional information from thermal loads. We need the thermal loads to pick up, for example, the equipment or sizing the ducts. So we are going to import all the elements of the different floors and also the different room types. We are going to click on finish and we accept the information window, and finally we're going to launch the environment, the work environment of this tool. So, for example, well, here we have, let's deactivate the DXF, for example. Okay. So here, let's establish the zoom. Well, this is the building, ground floor, floor 1, and roof. Okay. So we can activate the templates, as you can see here. We can modify the height of the installation for each floor. We have the elevation and the height of the installation by default, as you can see here. And we have also the 3D model here with the information of the architectural modeling and also the thermal loads elements from the calculation of the thermal loads analysis tool. So first of all, we are going to establish general settings. For example, the libraries for the rooms, we are going to activate, for example, the cooling temperature and heating for the different rooms and the dining room. Okay. What else can we import here? For example, the ducting. By default, the software proposes us the galvanized steel plate material, but I'm going to add a new material. For example, glass fiber. I'm more used to glass fiber for ducting materials, so I'm going to import these rectangular ducts composed of glass fiber. What else? For example, let's import some diffusers. For example, supply diffusers. Let's import some by default. So, for example, these two typologies for this flow, typical flows available for this design, for example. And what else? For example, some return grills. If you want to some exhaust grills, if you want, could be this input. For example, 125 and this one, these two typologies for exhaust grills, if you want to make some ventilation, for example, some exhaust network. So if we accept here, we just provide here. So what else can we see here on site? We can consult, we can see the total cooling load for the bedrooms, for the different typologies, for the corridor, for the room, the total cooling load, the heating load, and the ventilation flow we need. This is all imported from the thermal loads analysis for the CYPE loads. Okay, you see? So let's imagine that we are going to design some ducting sizing. So we are going to provide ducts here. This is the tool. Well, there are many possibilities here. For example, we can fix here, we can establish static this toolbar here. So let's pick up some duct, straight duct from glass fiber, rectangular, and supply flow. Okay, we are going to deactivate the rest of it. According to the supply diffuser, we're going to provide the different flow and consult checks. So, for example, let's imagine we are going to start from here, and we are going to provide some, let's imagine, this is not a real design for a house, but just an example, okay? So this is going to be, for example, this is dining room, some here and some over here. Okay, and finally some over here. Okay, this is my design. For example, let's provide some diffusers, supply diffusers. Yeah, the flow should be, for example, I'm going to pick up this one. And I'm going to establish, let's imagine, 60 liters per second, okay? As you can see here, the flow, the checks are matched here, and I'm going to provide some diffusers here, another one here, another one here, another one here, another one here, and another one here. Okay. So let's save the changes and just we can with this software we can just verify manually if our design, if we have blocked something, we can verify if it matches the checks, the verifications or not of the calculations, or we can make an automatic design, automatic sizing. We are going to make an automatic sizing, and you could see here. Let's go to the 3D view and consult this design. If we can deactivate, for example, thermal loads and all. Okay, here we have the design of this ducting sizing. You see?
Yeah.
The ducting sizing we have provided with the software, the automatic sizing. Okay, we can make another view if you want with some represent different. The special pieces, it depends on the joints. We will have automatic size or not, depending on the typical joints. For example, this one, if we come back here, if we consult the checks, we can click here, and this is the transition. You will see the information from ASRAE duct sizing design. We can provide this special joint or these special pieces for the duct sizing. So this is automatically also sized by the software. In the transition, the T's or the elbows, depending on the, for example, here we have an elbow. Okay, if we can consult, we have the code from ASRAE and all the information for the pressure drops, the flow, etc. Okay, also the diffusers. If we click here, sorry, in the straight ducts, we can consult also the information for the loss of linear pressure, the friction factor, the Reynolds number, etc. All the hydraulic calculations we have seen in these pieces, in each piece of duct of our network. If it's something doesn't match the verification of the results, the software is going to check and it's going to tell us which part is not matched or doesn't match the results or the verifications. Okay. So if we click here, we can modify and we can block here. For example, if you have to verify some particular size, some particular width, some particular height, you can modify and you can block it. If not, you can deactivate it and the software is going to analyze automatically. And here you can consult the text, the same thing as we have done clicking on the ductwork. Okay, you see, this is very nice because you can see in just in one design, you can consult and you can size automatically, or you can modify and verify the results manually. Okay. So here you have the reports. For example, here some ducts information reports. Okay, here we have each pieces of duct with all the information of the different nodes, the flow, the diameter equivalent round, the dimensions, velocity, loss of pressure, etc., and the material. This is also very nice in order to pick up afterwards the equipment, pick up the ventilators, the fans, etc., the fan coils we have to provide, and the material list. And this is also very nice because the software is meant to analyze and automatically size the different specialties, in this case HVAC, but also is meant to obtain some reports, some quantities, the bill of quantity in order to communicate with some estimate or budget software like we have here. For example, we can export this to Archimedes. Archimedes is our software to make bill of quantity of bill on obtaining the quantity measurements from here. We can export here the quantities of ducting and establish afterward the price and all the efficiency and the components, each individual components of each task for each element of ducting, diffusers, etc., and attribute or assign the price and obtain a budget execution material of the whole building. Okay, so we can export to this software Archimedes. But here you can obtain the quantities, and it's very nice. When you have a real building with a huge quantity of ducting and diffusers and grills, you can obtain the quantities here. You were telling something, or you were going to ask something, Buzik?
No, keep going. Okay, keep going.
Hello? Are you going to ask something, or just watch some noise?
Yes, keep going, please.
Okay. So, for example, let's just finish with this module. For example, if I make some ventilation here, I'm going to provide straight ducts here, glass fiber, exhaust. Let's imagine we have some toilet here. Let's go to grills, exhaust grills. Let's provide some with this size, some 60 liter per second. Sorry, 60 liter per second. We can modify the units at whatever point. So we can provide here in this point, we can modify the position of the grills, for example, and here we are going to provide a vertical duct from the ground floor 2.50, for example, to the roof, and the roof 0 meters or 0.5, for example. This is going to be glass fiber, exhaust grill, and we're going to accept, sorry, here. Okay, so let's come back to grow the roof, and you will see the ventilation fan. We size automatically. In the 3D view, we will see just this design for the exhaust ventilation network for this imaginary toilet or something, some local. We have to provide exhaust ventilation network. You see?
Yes.
How to do it? And this is the well representation in 3D for this ventilation network. This is the same. We can do it the same for the return network, the supply, or the exhaust grid. So if we export this, well, obviously also we can obtain the drawings. Maybe this is very interesting also for some mechanical engineers like me, for example. Well, we have to provide a different, let's provide some floor 1 and the ground floor. So the drawings in 2D, also we have imported templates in 2D for the modeling. And also we can export the information for the different results, the calculations to, we can print in paper the 2D results, drawings in PDF or in paper or in WWG or DXF. So we can return the information to your CAD software in DWG. So here we can tell drawings and you will see the information. This is customizable, the information you want to provide for the templates, for the drawings for each floor. So here's the information for the execution plan. This is very nice. We have to provide the flow, the size, the reference notes for each pieces of duct and also for the ground floor. You see? And also we can print it to a DWG one file, for example, HVAC design. So let's display the file with the, yeah. Continue opening the DWG file. So this is a DWG file you can work with your CAD software, your BricsCAD you were telling your Benjamin, or your AutoCAD or your SketchUp or whatever software you use to manage your DWG files, or DXF, as you wish. You understand?
Yes.
Yeah.
This is quite nice for us, for mechanical engineers, in order to provide the results in 2D result, 2D information plans or drawings. Okay. So let's export the results to the BIM projects. HVAC installation Korea, for example. We accept here. Accept. Let's wait until, let's see if it's. And well, yes, it's synchronizing. You see that it just finished synchronizing. Let's refresh the project here. First of all, we will see the 3D view of the dashboard. So we can, the HVAC installation, you see here. Let's deactivate a little bit. Okay, so we have here the information. So this is quite nice because, for example, let's establish this axis here. Well, I'm not very good at this, but here you can see the information of each pieces of duct, and let's consult some information. If I double click here, you will see the reference of these pieces of duct, dimensions, and the flow. So directly in the platform, you will consult the information. You see? This is also quite nice for all the team members of the project to have access to this information in 3D. So this is the whole design, ducting design. And if we come back to the files, we will see HVAC installation Korea. We have some DWG results for the drawings, the PDF for the ducts. The same we consult directly from the tool. Here we can consult here in the platform in PDF. You can download it, you can print it, wherever you want to do. Also the material list, the quantities. This is quite nice also. And the GLTF on the installation. Remember, as always, you will have the information in your user of the BIM projects. This is my user. And here in the information, we have all the IFC results and the different specialties. HVAC, a local copy in your computer. Remember that. You understand that, Buzik? Are you following?
Yes.
I'm just showing the information is always stored in your local copy in your hard drive, okay? Or not only in the cloud. So this is the result from HVAC. Maybe we can finally we can show you some. We have the OpenBIM icon here. For example, we have this tool, for example, for the store. Just to finish this little overview of today. Here in the store, I'm sure you were shown this tool last week. So we have, for example, for HVAC installations, we have some tools apart from HVAC. We have just shown of cyber loads, etc. We have these OpenBIM systems, for example, from Toshiba. Again, there are free applications for the particular solutions. Also for underflow heating, you could use it and establish the underflow heating solution for the polytherm. But for example, I'm going to show you the OpenBIM Toshiba because I have downloaded in this computer. So let's, it's unzipped or not?
No.
Okay. I'm going to install it quickly. It's very, very easy to install it. So, do you have any questions? Meanwhile, I install this tool. Sorry, excuse me, do you have? Sorry, I have to close the sequence. Close. And I don't have any more tools here. Okay. Do you have any questions or not for the moment?
No, yeah.
Oh, no, not for a moment. Okay. More or less, everything is more or less clear. Today just was the target is just you have the idea of what is our target and how we do it, which tools we can manage, we can use to in according to accomplish the different domains or specialties of in building design. So I'm explaining to you a little bit the workflow of these OpenBIM tools. Well, just to finish this, I'm going to show you this OpenBIM Toshiba. For example, VRF design Korea, or split or multi-split, or so we accept here, select the project. As you can see here, it's always the same with the different tools. The process of starting is to connect to a BIM project and import the BIM model. So set the loads, HVAC, you want to see the ducts, import the groups and floors and the rooms. You can accept. So here we have, I'm going to deactivate the template. Okay. So, well, as you can see here, is more or less the same aspect, the same environment that I have shown you with the Scepter and HVAC. So here we have the climatic conditions. For example, let's pick up Korea. Again. So we have the information of the different cooling loads exported from Scepter loads, and all the information, geometrical and dimensional, from the BIM model, all the ducting sizing here. So here we have some different tools to provide VRF, aerothermal, multi-split, or a split 1x1, for example. And what we can do here, it's just starting, for example, going to the roof, yeah, and going to the roof. Let's provide an external unit here, a VRF outdoor unit. We should be consulting the total cooling loads we have provided on the separate loads in order to pick up the external units. Let's pick up some unit, for example, this one, for example. I'm going to provide it here. And I'm going to establish, for example, the in floor 1 and ground floor, the different internal units. For example, ground floor, let's provide some, this is a cassette unit, for example. This one, we have two different elements, for example, with this total power. Let's provide, for example, this one here, another one here, and we are going to pick up another system, for example, a wall one here. And let's reorientate this one, for example, with this one. Okay, so here we can rotate if you want, and be parallel to the wall if you want, so we can rotate it afterwards the introduction. So this is not mandatory, but you can do it if you want to represent properly in the drawings. And finally, we have, for example, another unit, for example, could be a duct distribution unit. For example, we can provide a standard series, for example, high pressure or low silhouette with different bats, for example, this one. We could provide for this one, for example. Obviously, we could move that and establish wherever we are going to provide according to the duct distribution. And finally, for example, another wall ones here, another one here, and another one over here. Okay, so once we have all the internal units, we can refresh the 3D view, and you will see the 3D view. Okay.
Yes.
So this is a representation of the unit, the external and the internal units of this OpenBIM Toshiba system. Okay, you see. So let's connect this with the piping. So let's move on to the ground floor, and we are going to provide a horizontal pipe from just, well, more or less here. And we are going to provide a floor one, and we are going to activate the roof here. So here we are going to establish the horizontal piping from here just up to here. Also here, from here, and from here. Okay. So I'm going to establish now the vertical piping. So here we have the vertical piping. Now the vertical is meant to connect the ground floor, the roof unit with the different floors, different units in the different floors. So here I'm going to activate only the roof and the ground floor. Yes, not the floor one. So horizontal piping here. Okay. This one on here, and finally this one just up to here. Sorry, this one. Okay. So let's save the changes and see if it's everything is properly defined or I made something wrong. Using maybe I made something wrong with the vertical units, the vertical piping. Let's verify in the 3D view. Okay, let's introduce again the vertical unit. Again, ground floor, vertical pipe. Here we have. Here we have. Let's. Okay, these are well properly connected. Let's refresh the 3D view. And the ground floor is maybe something wrong here. I didn't connect. Yes, sorry. Yes, tell me.
Yeah, delete. Warning. Delete.
Yeah, we have some error here because it's not really, it's disconnected from the installation. I'm going to reconnect. Maybe yes. I have some. Let's connect here, over here, and oh no, there is no unit here. Sorry about it, because the unit here. Sorry. Because we are in the floor one and we have no unit here. Sorry about it. Yeah, yes, it was my mistake. So let's go to a 3D view. Yes, I was making a mistake here. So here we have. If you want to, we can deactivate. Another interesting thing here, it's apart from calculating and see every specialty, we can consult obviously the visual inspection of the clashes. If something of the HVAC installation, for example, the ducting sizing is crashing or overlapping some elements of the BRF elements or something like that, it's crossing or clashing, we can detect it here. Or imagine that we have provided the fire protection, the plumbing, or the electrical installation trace, for example, we could verify that is something clashing or something we can make a visual inspection. And in the future, obviously we will make some remarks, some warnings that we have something that is overlapping. So this is the idea. For example, this is obviously is not well properly defined because we have some ductings, clashing, and internal unit. But this was just an example. Here we have the results. of the BRF and the material list as the other calculations. We have all the reports for the justification for the results here and the material list for the quantities. I insist on this because it's very interesting for taking into account afterwards for the deducting, for the quantities and for the bill of materials, okay? For the refrigerant piping and the quantities of each element. We export the results. The schema of the BRF is also interesting to consult here. Okay, this is quite nice. In one schema, you could see the behavior of your installation of the design of the BRF system. Also, we can obtain the 2D drawings, the schema of the floor plans, for example, roof, ground, and floor. Let's finish it. Details, and we could see the different designs. Okay, this is the 2-pipe gas liquid of refrigerant piping here, and we could print out and save it into a DWG file, BRF design, for example, into a DWG file. Okay.
Yes.
So if we close the loop in to export to the platform, we will see the information for Toshiba. Let's establish Toshiba BRF, for example, design, Korea, and we accept to the IFC results. Wow. Let's go. Sorry, I closed the synchronizer, so I must reboot it or relaunch it. Yes, it was closed because I closed it to install the OpenBI Toshiba tool, so I have to, yeah, now it's synchronizing, you see? So if let him finish, yeah, come back here, projects, go to Buzik test project here. So here in their files, for the moment, yeah, well, now it's Toshiba BRF Design Korea. We have the drawings, the PDF materials, and the reports. And also in the dashboard, we will see the representation in 3D. So let's make transparent this one and activate this one. So this is, well, obviously I can change the height of all the piping. This is not really realistic. I mean, because normally we don't lining on the roof, but we can modify whatever point because I didn't realize that. So this is what the 3D view is nice because you realize that some mistakes you have made on the design. So this is the information. We can, as always, make some cuts here and consult the info here. This is also nice because if we double click on the units, we can consult the total power, the required, and also the model, the series model of the BRF of Toshiba reference. So this is for the internal units, and for the external units, the same thing. Okay?
Yes.
And in the piping, the same thing. If I double click on the piping, if I match, this is the length and the dimensions for the piping. So, and just, well, with this, I finish with this. Remember always, if you start with IFC Builder, for example, one thing we can do is to come back to return the information to the original modeler, IFC Builder. This is Korean 3D model. And this is the file well, in theory, Vincent used to model your building in 3D. Remember this? So here, let's, well, maybe should, I don't know if I'm going to be able to update. Yeah. So This is because it's connected to the project TestBusy project, so I'm going to update with the information of all the specialties. Remember, now imagine that I'm the role of the BIM manager, the one who created the BIM modeling, the 3D model of the architectural modeling. So every specialist, every engineer, structural, mechanical, electrical, acoustic, plumbing, etc., is doing their job. And it's going to export to the platform. So I'm going to accept here, the information is returning back to my modeler. So here in the 3D view, I will be able to see not only the architectural model I've made, but also the information of the different specialists. You see?
Yeah.
This is the of the edges. I can deactivate the walls, for example, and the floor slabs. So here I'm going to deactivate also in the BIM model, for example, let's deactivate thermal loads. And this is the representation of the different specialties here. So this is in the original phase of the architectural modeling. I can come back, I can see the information always in the V1 3D viewing of the total model, the whole model. Okay, this is like closing the loop of the whole process of building design. So I don't know, on my behalf, I think I finished. I don't know if you have any questions, Mr. Buzik, about what do you think about this process of this workflow? Could you give us some feedback?
Yeah. So just a very short time period, you build the IFC model, and in addition thermal and HVAC, and also the Toshiba equipment layout. So yeah, it's a quite efficient tool to
Yeah.
make yeah.
Yeah, I know that there is a very short presentation because we have many different tools. Yeah, and you can see here, not only in the platform, in the store of the platform, but also in CYPE Suite and in the MEP Suite. We have sanitary systems, we have water systems, we have lighting. We have Acrobat Beam for acoustics analysis. Also, we have hydraulic systems for fire protection. So we have many different tools. It's impossible to see in 1 hour and 2 hours time. So just it was the idea was just the whole idea, this general idea of the workflow, how to create a project, and also to show you that you can work with your templates, that you need to clean a little bit the template, simplify a little bit, get used to the workflow, use your templates to import to IFC Builder, for example, and create your BIM model starting from your templates and starting your BIM workflow, communicating with the different open BIM tools. This was just the idea to show you that we can it's possible to do it with your building. Okay.
Yes. So yeah, very brief introduction of your tool, how to apply it. So we have a quite good understanding of what your tools can do. So,
okay. What I suggest you, or what I recommend is just to test it and to just really practice with the software. For example, with this particular building or with another buildings you have, maybe to start with, well, maybe you could start with this building or another simple one, and start working with starting from the modeling, and afterwards working with the different OpenBIM tools and making the calculations, exporting and importing in the platform, synchronizing, and etc. And if you will, obviously, I'm sure you will find some troubles, you will have some questions, a lot of queries, and don't hesitate to feedback us and to contact us.
Yes, we will do that. Yeah. So my staff will exercise its topic, its tools, and will just contact you if any questions.
Okay.
Okay. Well, you know our emails of support.
Yes, you know that you can send me your questions or directly send the email to support@site.com.
I'm going to write you on the chat just in case, or I'm going to show you in the website. Maybe it's the. Okay, so you know our YouTube channel. You have seen?
Yes.
Okay.
Yeah. So yeah, we will investigate more
Okay.
on your website. Yeah.
Okay. So this is you have this technical support address apart from the one from Vincent. So you have this technical support address. So wherever problems or technical questions or handling questions about the software, don't hesitate to contact here or Vincent, and we will try to answer as quick as possible to you.
Okay. Yeah. Okay. Okay.
Okay, Mr. Tek, very nice to meet you. Thank you for your patience today.
Yeah. Thank you, David. Yeah.
How many of you are there?
Yeah. 4, 3 more except me.
Okay.
Okay, so
Well,
hello to everybody.
hello to everybody. Yeah.
And let's see if you try to practice a little bit and we can meet maybe next week or
Yeah.
when. Okay.
Yeah. Next week. 이번 주에 또 한번 더 할까? 아니면 so sometime next week. Yeah. The remainder pure the topic structure and fire protection.
Maybe, yeah, would be nice.
Yeah.
Also, I suggest you if you create your people, you guys, if you have already an account, Buzik.
Pardon?
Yeah. I was telling. Yeah, do you have already an account?
This one.
No, but this is my.
This is yours.
Yes. Buzik.
Yeah.
Okay, I'm going to invite you to the project in order if you want to try some things or test. Okay, this is you. So you have also the projects here, add to contacts. So
Yeah.
I'm going to add you as my contact, and I'm going to invite you to the project. So yeah, work team, invite you. I'm going to. Okay, position. So moderator, if you want, okay. So you have already an invitation to collaborate to the project, okay? In order to try to test it or to make whatever you want. Hello?
Okay. Yeah.
Perfect.
So
So you will have a notification on your platform or your email about an invitation to collaborate here.
Okay. Okay. Thank you very much. And any question, please send me an email and we keep talking. Okay.
okay.
Okay. Thank you very much. Have a good day. Bye.
Thank you. Bye bye. Yeah.
Bye.